Here at ITF, I am with Philippe Absil. He's Vice President of IC-link, imec Silicon Solutions. Philippe, what is IC-link?
IC-link is imec product services. So we are enabling companies with product services. Of course, imec doesn't make product by itself, but we are enabling access to novel technologies, advanced nodes through IC-link, but also to advanced technologies that imec is able to bring to the market when foundries are not ready to do so.
Here at ITF, we are seeing some of your largest collaborators showcasing proudly that they are collaborating with you. But I want to talk about silicon photonics.
Okay.
What's new on silicon photonics?
Okay, what's new right now? Of course, 200G per lane is really driving the ramp up of volume, and there are a few small technology innovation that is needed in order to enable that. But what we are really working on now is to do towards 400G per lane and to enable LNO, lithium niobate integration with silicon photonics, and combine that with more advanced detectors that can reach more than 100 gigahertz of bandwidth in order to really address the 400G per lane optical device challenges.
All this heterogeneous integration happens in collaboration, I suppose, with other entities.
That is correct. And right now, of course, we collaborate with our close partner, Ghent University, in order to enable that, but also other partners that are providing state-of-the-art lithium niobate devices that we need so that we don't reinvest into building our own lithium niobate line. We are working with partners to do that. And then, of course, eventually to enable foundries with the technology, because imec in our fab, we can only handle very limited volume. And with the booming of AI, we know that 200G per lane, 400G per lane, that is high volume, much higher than what imec can enable.
Let's talk for a bit about indium phosphide on silicon. At the IC-link booth, you already have a wafer of indium phosphide technology on silicon photonics. What is the future, your preferred future for this platform?
So again, like lithium niobate, where we are looking at transfer printing in order to enable that. That is a flexible way to do it, but we also see benefit of doing die-to-wafer or wafer-level reconstruction, actually, and that's one method. That's maybe more large volume manufacturing method in order to enable that. Of course, it requires to have advanced processing in the CMOS fab in order to enable it. So the flexibility that imec offers is to pave the way with these novel technologies in order to bring it to the market and offer it before the big foundries would be ready to do so.
In today's technology, in today's silicon photonics landscape, we are seeing lots of new materials coming. We talk about Thin Film Lithium Niobate. We heard lots of good stories about BTO. People are talking about, indium phosphide quantum dots coming to the market. What is your preferred future? Do you think we are going to standardize a bit the amount of materials in silicon photonics?
That is complicated. What I see is that different specific segment of the market have different needs, and for some of them, EAM will be acceptable for short distance and longer distance. LNO is preferred. So it is challenging, because also when you look then back in the next wave of innovation will be on CPO. Whether lithium niobate can make it for CPO, it's an open question. Lithium niobate offers, of course, great advantages in bandwidth and loss, but it's not compact. So then we're looking also at alternative solutions that maybe are less efficient but more compact. So different trade-offs. It remains very challenging in photonics to have like one solution that fits all needs at once.
And silicon photonics manufacturing is complicated. The packaging of silicon photonics is also complicated. We have seen new designs of CPO, the presentation by NVIDIA a couple of months ago. They're talking lots of fibers coming into the CPO. Are you working on that as well?
So part of our research program. It's not something that we offer as a service yet, but the intention is to offer that as a service. And we have a few collaborations in the space with companies that are bringing innovation on this problem. Yes.
If we had this conversation again in ITF 26, what kind of things would you like to tell me? What is your preferred future for the next 12 months?
I think identifying indeed a packaging flow where we can also offer packaging services for photonics, and testing services also. That's something that people underestimate, but actually having an efficient testing that is adding value to the final die cost is very important and underinvested right now in the full ecosystem. So those are two axes I would like to grow. And then announcement that we have a pilot line ready for lithium niobate integration. And when I say pilot line is ready for ramp up, so already available at the commercial foundry. So that would be ideal communication in 1 year.
How other companies can help you?
How other companies can help you? Well, we are talking partnerships on the test equipment, for instance. We are talking partnership on the lithium niobate sources, diversifies the supply chain. So we are discussing this with our partners.
Congratulations on everything that you are achieving and on all your collaborations. I'm happy to be one of them. See you very soon.
Thank
also
you,
at the
Jose.
ITF Malaga in a couple of months. Thank you.